no reason for us to memorize any of this. Really, quite honestly, all we need to know is our two special right triangles.
60, 45, 40, or 30, 60, 40.
I knew what you meant.
So are we actually in 14.4? It's been a while.
Yeah. Yeah, I jump around with this stuff because this section uses inverses. Really nothing else after what we did yesterday uses inverses. You go into graphing and working through all that other stuff, which is fine, but knowing how to set up and solve trig equations, you have to solve via an inverse, because when you're solving an equation, you're just working inverse operations. So why not use inverse operations with trig as you're going through it? That's basically what we're getting at today. Now, as we know, your cosine values are your x, your sine values are the y coordinates. Tangent is then y over x. Today we'll probably not have time to get into the reciprocal functions. We probably won't solve equations today with cosecant, secant, and cotangent, but we will start with some basic stuff without too much of a hassle. Also, yesterday when you guys were solving your you're solving those quick trig equations, for example, if you had what angle had the sine value of root 2 over 2, that was saying that, or I'm sorry, write this as a negative. That was saying that you were looking for values, what angle gave you that sine value. It would have been 45, correct, but we would have said that it was between here and here, and it would have been negative 45, and we would have said negative pi over 4. Okay? What we're going to do today is we're going to find a solution within one revolution. Okay? We're going to find solutions of theta or x that are between 0 and 2 pi. So we're going to find out all solutions within one round of the circle, but we have to just remember this. All students take calculus. Because it's nothing more than using reference angles again, and then just placing it into the correct quadrant to figure out your angles. All right? So up to this point, it's been pretty quick. Hey, special right triangle, get a reference angle, move to the correct quadrant, and go from there. So, like I said, it's quite literally adding basically 2 steps to that problem. Let me show you. If I want to solve this is not a general solution. We'll do that later. If I want to solve 2 times the sine of x minus 1 equals 0, if I want to solve for x, and I'm going to solve for x within one revolution of the circle, between 0 and 2 pi, I just need to solve for x by working backwards. So if you start with 2 times the sine of x minus 1 equals 0, what's the first thing you need to move?
The 2.
The 1. The 1. Think of this as 2 times x minus 1 is 0.
Okay.
So you have 2 sine x is 1, then 1, divided by 2. Sine of some angle is a half, which means x is going to equal the sine of some angle, or some angle has the sine of 1/2. What angle has 1 as its opposite and 2 as its hypotenuse? Hypotenuse? That thing too. The hypotenuse.
60. Wait, adjacent.
So adjacent, I'm sorry. It's okay. The opposite, what angle, what theta value has 1 opposite it? 30. So that means that sine, that means that it's going to be at 30 degrees, otherwise known as pi over 6. But if I'm looking at it within one revolution, what other quadrant has sine positive? Quadrant 2. So if my reference angle is going to be pi over 6 here, that means as I spin into the second quadrant, what's that overall angle?
150.
Be 150, otherwise known as 5 pi over 6.
So it's going to basically be like having 2 coordinates.
Pretty much. And that was the idea of, as we were doing this before, if you know what one set of ordered pairs is in the unit circle, you can mirror that to bounce it into all 4 of them by changing their signs, S-I-G-N, as you move the ordered pairs. So the y value doesn't change from first quadrant to second quadrant. That means that your sine, S-I-N value is the same in 1 and 2. That's what you're doing.
Wait, so there's two angles then?
Yeah, there's two angles within one revolution of the circle that will give you, if you type in your calculator, if it's in degree mode, if you type in the sine of 30, it'll spit out 0.5. If you type in the sine of 150, it'll also spit out 0.5. That's all. That's what it's doing. Okay? Let's do another one. Now I have that song in my head.
It's stuck in my head too. Like along with some orchestra music, it's weird.
So 4 times the cosine of x plus 1 minus 2. Gee, what do you think you do first? Subtract the 1. Woo. Oh no, I'm at a loss for words. What do I do? Divide by 4. What's negative 2 divided by 4?
Negative 1/2.
Very good. Cosine of x is negative 1/2. Is it okay that I skip writing it out as negative 2 over 4 and then rewriting it? Absolutely. And in all intents and purposes, eventually you're going to see this and you're going to be able to write x is going to equal the inverse cosine of negative 1/2. You'll be able to skip right to that. Don't worry about it. We'll be doing this for the next 3 days or so because these start pretty quick. Get kind of tough.
No. You never do.
Where is cosine as you start the circle? Negative. It'll be, oops. It'll be, it's negative 2 and 4. Okay. So when you start thinking about it, you start placing it 1/2. That means your adjacent is a negative 1. Your hypotenuse is 2, which means your opposite is the root 3. What angle has an opposite root 3? 60. So that means that this is a 60-degree reference angle, or a reference angle of pi over 3. So what's the angle that drops to the second quadrant with a reference angle of pi over 3? Yeah, you're saying 60 is 120, so it's going to be at 120 degrees, or 2 pi over 3. Yes, ma'am?
How did you know that it would be over in that quadrant?
Because it's negative, and I know that cosine is an adjacent. Choose the hypotenuse. Calculus is, remember, all students take calculus, that's where it's positive. Those are all where it's positive. So remember,
Wait, so we basically want it to be in a place where it's going to be negative since it's a negative 1/2.
correct.
Okay, because I thought you said the fourth quadrant or something would be the next one.
Oh, did I say that? I did, didn't I? I'm sorry, I was thinking, I mistakenly spoke that. I apologize.
So it's going to be in
2 and 3. So now if I go to the third quadrant, I have to move down 60 degrees, or I'm moving down pi over 3, which means that the angle down here is going to be at,
no.
4 pi over 3, and if you add 60 to the 180, it's 240.
Wait, but if you go down like that, isn't it negative 1 over negative 2? No, because
It is, but I'm still worrying about, I'm sorry, it'd be negative 1, it's down negative root 3, it's over negative 1, down negative root 3, but the hypotenuse stays positive. I think that's what someone was smart to say over here too. The hypotenuse will always stay positive because of Pythagorean theorem.
Okay.
You're just, even though you're walking a negative value, because you just went a negative direction. Negative direction squared is positive. Negative direction squared is positive. Adding 2 positives, you're still going to get a positive. Okay. Yes, ma'am.
Why did you flip it? I mean, like, I don't know how to, but like, so we're at 120. Why didn't you go on to 240?
Because the other quadrant that cosines are negative is the third quadrant. So by flipping that, that means it still has to have a reference angle of 60 degrees. So 60 degrees off of 180 is 240. Pi over 3 off of pi is adding 1/3 to a whole. That's where I get 4/3. This is where we actually are using reference angles to solve the equations as we go through. This is where bouncing the reference angles come into play.
So what would be the final answer?
Those two. This is my answer. I have two solutions.
So instead of like two, like a coordinate like x and y, it's like two angles?
Yeah. Two values of x that make that solution true. If I used my calculator and I did 4 times the cosine of 120 plus 1, it'll equal -1.
Is this going to turn into like x squared plus 2x?
We'll get there. Baby steps. And if you can solve a 2-step equation, a 3-step equation, you're going to be fine. Root 3 times the tangent of x minus 1 is 0. What do you do first?
Math.
Math. Very good. What math do you do first?
Add 1.
Yeah, 1. That makes sense. Now what do you do? Divide by root 3. So again, the tangent of x is 1 over root 3. You're right, it's going to be root 3 over 3, but now, exactly. Don't, yeah, you got it, Hopper. You don't, when you're solving the equations like this, guys, there's no need to rationalize it, because in your mind, what you're going to ask yourself is, what angle has a tangent value where 1 is your opposite and root 3 is your adjacent? Because if you rationalize it, you'd have to say, okay, it's root 3 over 3, which means if I flip it around, it'd still be 1 over root 3. You could do it, but then you'd have to back it out anyway. You know what I mean? So by looking at it like this is the case where I would say, hey, I really don't need to take that extra time to rationalize, because tangent value positive, well, that's going to be first quadrant right away, which means my opposite is 1, my adjacent is root 3, which means what angle am I? 30.
Which is 150, so 150 equals 5, 5, or 6.
Ah, careful. So I'm at 30.
But isn't it all in the first quadrant?
It would be in
I thought it would be in the second
go
quadrant.
over one and then up.
Tangent is opposite over adjacent.
Yeah, but wouldn't it be in the second quadrant because it's
That would be in the third.
It's going to be in the third because these are positive, positive. These are negative, negative. What's a negative divided by a negative?
a positive.
That's why it's going
Wait,
to
so why does it have to be positive, positive? Like, why does it have to be positive though when like the other ones were in the negative?
Okay. Tangent is y over x.
And that's always positive.
When you have a positive divided by a positive, it's positive. In the third quadrant, the tangent value is going to be a negative y over a negative x, which is y over x.
But like the other one, like the one we just did before, like the 4 terms of cosine of x,
Uh-huh.
those two were in, it's like, it wasn't in the all or the calculus, it was in the two ones that would make it negative.
Because we were looking for a negative. What angle has cosine that's negative?
Okay, so like if it was negative 1 over root 3, then it would be the other two?
Then it'd be 2 and 4.
Okay.
Okay. So here, you're looking at 30 degrees, which is pi over 6. And then I have to come to the third quadrant, which means I move down pi over 6. So what's a sixth more than a whole? 7 pi over 6. So you're at 210 and 7 pi over 6. Again, there's two angles that satisfy this solution. There'll be two angles that satisfy the answer.
Yeah.
Okay. Yeah.
Are there any where you go negative for it or would these all be positive?
What do you
You
mean?
could go like, as you said, it's 7 pi over 6, but you could also go negative 5 pi over 6.
The parameters will be between 0 and 2 pi.
Oh,
So you don't
yeah,
have to,
negative.
yeah, you don't have to worry about that. And it's usually what happens. And then on Monday, I'm going to show you guys something that's called a general solution, which is kind of the same thing with an extra step. You don't have to worry about trying to find the negative coterminals for these things, okay? We'll worry about coterminals later.
Is it sine of x times the tan of
It
x?
is.
Sine times
It's the sine of x times the tangent squared of x equals the sine of
Well,
x.
the first thing you do is take on the sine of x.
You can't. If you do that, you eliminate a solution. Remember how we did that before with polynomials? If you divide out by an x, you got rid of a 0, didn't you?
Wait, so it's the x is like a times?
No, this is the sine of x times the tangent squared of x.
Okay.
So,
Do you just factor
yes.
this?
No, not FOIL, we're gonna factor something here. I'll show you in a second.
Oh, so this is where the x squared thing.
Yes. Okay? So, just like you did before when we had polynomials, if you divided out a term of x on both sides, you eliminated a solution. That was a common problem that you guys did before. If you had like 8x equals x cubed, you divided out by x, you had 8 equals x squared, and you missed out on the 0. It was actually a cubic function that changed direction on at 0 and stuff. This was a thing that, it was a mistake that most people make before. You cannot do that, okay? So when we had this, where it was, x cubed equal 8x, in order to really solve this problem, you had to set the side equal to 0 in order to get it to work. Because then you'd factor out the x, and then you'd have two solutions. You'd have 0 and plus or minus 2 root 2. Because it was a third degree polynomial that could have 3 possible zeros.
Wait, so then if you move the sine of x over to one of the other sides, like,
You get,
they won't cancel out?
nope, because this is multiplying. So this is sine of x times the tangent squared of x
Oh, divided by.
minus the sine of x
What's sine of x divided by sine of x?
is 0.
Why minus?
Because I moved it. Is it positive on the right?
Right, okay, I thought it was
So
supposed
what
to
if
be
it's
divided
sine
for some
of-
reason,
what
like,
if it-
I was thinking logs.
It's gonna be just because it is multiplication, so can you do sine x divided by x? Now there's
No,
sine x
because if
minus
I-
sine-
Hold on. Back to this problem here. If I divided by x, what happens?
Oh, yeah.
You can't do that because you eliminated a possible 0. Same exact scenario, we're just putting the word sine or tangent in front of it. You- we don't know that. I'm just showing the algebra, if you will, of why this is the process, why you have to do that. Now, you've got junk minus junk equals 0. To the two terms between the subtraction have something in common. What do these two parts have in common? Sine. So just like I did here, I factored out something, didn't I? So factor out a sine.
Oh, that's because it's multiplied.
And just like you have x times the quantity x squared minus 8 equals 0, now I have sine of x times the quantity tangent squared of x minus 1. Those, do I have two terms? Are both those terms set equal to 0? So now I just set both of these guys equal to 0, and I wind up having to solve two equations. I have two separate equations to solve independently of. Alright. So this turns into a problem like you did yesterday. What angle has a sine value of 0? So that means it's going to land on a quadrangle. Sine is going to be 0 twice within one revolution. That's your y value. Well, y is 0 at 0 and pi. Okay? We all right with that? Because this ordered pair is 1, 0, this one's negative 1, 0. So my solution here is x is 0 and pi. Move this up a bit. The other one, treat it as a two-step equation. First thing you're going to do is what?
Take out the one.
Not take it out, you're
Move
going
it
to
over.
move it over, yeah. So you move it over, you get tangent squared of x is 1.
And then you move the tangent square.
No, how are you going to do squaring?
Yep. You just square it.
Square root it. Am I taking a square root over an equal sign?
Yes.
What happens when you take a square root?
Plus and
Plus or minus. So now you have the tangent of x is, what's the square root of 1?
1.
1. Now you're at what angle has the tangent of 1 or negative 1? Well, this one's pretty quick because where is tangent equal to 1? 45. At every single 45 at every 45 degree angle, tangent's going to be either 1 or negative 1. So that means that all of your reference angles of pi over 4 work. So that means you're going to have a list of these. Pi over 4. We're going within one revolution, so I'm just going to go pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
What about the negative 1/16?
These are always going to be within one revolution. We start at 0,
Oh, right, 'cause-
and we come around. That's why it's a little bit different than yesterday.
So in one revolution, you always go like it's positive?
Yep.
Okay.
So technically, this equation has 6 solutions. What's that? You could, but it's not worth it. Because what you want to worry about is if you know that if you can do the sign of 0, hit a button, it's 0, you're fine. Sign of pi, hit a 0, it's 0. If you type in tangent, is tangent of 45 1? Yes. Tangent of negative, or tangent of 135? Yes. 215, or
225.
225. It's 230, so it's close.
So do you not want us to put the grading measurement close to?
I'd rather you not. I'd rather stick to radians on these things. A lot of times it'll ask it for it'll say your parameters between 0 and 2 pi. Yeah. Or it'll say between 0 and 360. I would try and keep going to radians.
Oh, I
For
forgot.
one more class tonight,
And add them both.
I just did both for like practice.
Oh, sorry. Skip 21, but do 25 instead. So actually I should have written 19 through 25, skip 21.
Yeah. That'd be a lot easier.
Yeah, it would have been a lot easier. Number 21 has, it's the sign of negative x. We'll introduce you guys to negative angles next year. I gotta leave something for pre-calc. Okay. These are all going to be within, all of these answers is going to be, x is going to be between 0 and 2 pi. Think of everything between 0 and 2 pi that give you the answers for these equations. As we get into next week, we'll add more of the factoring, a little bit more of the inverse functions and stuff like that. Yes, sir?
Which chapter is this?
This is 14. Yeah, this is 14.4. Sorry, I didn't write that down. We're kind of skipped around a little bit. All right. I could probably pop this up here real quick too. Oh, sorry. Yes. One of these tabs, if I can find it. That didn't show up very cleanly.